Well, good morning. Welcome, friends and colleagues. This is our annual David Heimbach lecture. Dr. Heimbach was a prior burn director and helped found our center. And thanks to his work, this is how he laid the foundation of what kind of burn center we are today. So we're grateful for him and his legacy. In burns, we've been interested in the topic of climate change for a long time, as our clinical service treats patients with many of the acute consequences of too hot and sometimes too cold. And we live in a society that's fraught with deep inequities and insufficient safety nets. So we looked for an expert on this topic, and we found him in our own institution. And so we are very lucky that Dr. Hess has accepted to speak to us today. Dr. Hess is currently a professor in 3 UW departments in emergency medicine, environmental health sciences, and global health. He's a world leader on the impact of climate change on health and authors multiple national and international assessments on the health impacts of climate change. So the questions we have to you for you, Dr. Hess, are: what are burn providers supposed to do to get prepared, and what can surgeons do at large? Thank you.
Thanks very much for the kind introduction and really for the invitation to be with you today. I'm very gratified. I'm gratified because our departments have long collaborated successfully and productively and happily and with a real commitment to addressing inequity and serving people who are marginalized, which I really appreciate as part of what brought me here. But I'm also gratified to come and speak with you to learn about your commitment to these issues and to learning about how we might better prepare individually as practitioners, collectively in medicine, and then as part of the large anchor institution that we are for not just Seattle, but for the whole region, and leveraging our important role in training and service provision in that space. So, as Sam said, I'm going to speak with you about climate change and surgical care, starting broadly, but focusing in pretty quickly on frostbite and burns, and then talking about some opportunities to learn and sort of keep track of these issues as we move forward. Starting with the obligatory disclosures, I have some research funding, a little bit of honoraria sprinkled in there for some academic work over the last few years. From my point of view, none of it really affects my judgment, but I'll let you decide. So the overview of what I'm going to cover with you is I'm going to go over climate change. I think all of us have a pretty good sense of what it is, what's happening. But I like to clarify exactly what the mechanisms are, because they're quite simple, and people often, in this country, and really this country alone in the world, there's a lot of debate about this. And these mechanisms are quite simple and incontroverted, honestly, for hundreds of years in physics. And so I like to reinforce that and then look at some of the impacts and consider the timing, because the timing is probably the most important part of the whole thing. And then talking some about intersections with surgical care and specifically thermal injuries, frostbite, and then burns from exposure to hot surfaces and wildfires. And then we'll talk a little bit about how to synthesize it all and think it through. There are some learning objectives that I think you've already been exposed to. Basically, I want you to be able to describe the impacts that I'm going to go over, explain the relationships between climate change and these environmental impacts, the exposures that people are facing, how they become our patients, and impacts on the care you provide, and then strategies for addressing these intersections. So, climate change is principally driven by the emission of carbon dioxide, but there are other greenhouse gases that we're putting into the atmosphere. There are 3 major longer-lived greenhouse gases that we're putting up. Carbon dioxide is about 75% of our emissions. There are a number of short-lived greenhouse gases that aren't on the list here, and those are actually quite important. They're very strongly forcing, meaning they have a strong global warming potential. And importantly for us and for surgical care, some of them are inhaled anesthetics, and they're a large part of carbon footprint of healthcare, which we'll come back to a little later. But you can see this is annual emissions globally. And what you can see is, every year on year, we've gone up until pretty recently. And that little dip at the very top there is from COVID pandemic. And then we went right back. And then this year we went up a little bit more. I didn't have a chart on that, but imagine a data point right up there. Essentially have plateaued. So, which is good news, though what we really like to see is a drop. But we plateaued. That doesn't solve the problem, because as you can see here, atmospheric concentrations continue to rise. And that's because a lot of these chemical species are resident in the atmosphere for dozens, and in the case of carbon dioxide, probably hundreds of years. Average is about 100. So the influence is felt long after the emissions, as they are up there, and it's very difficult to remove them from the atmosphere. So even though we plateaued, we'll continue to add to that atmospheric stock, if you will, and the influence will continue to accumulate over time. So as mentioned, there are three basic physical relationships at play here. And the first is that those greenhouse gases, they go into the atmosphere and they support additional heat retention on the Earth's surface. Basically, radiation from the sun comes through the atmosphere, warms the Earth's surface, and then is re-radiated back up. Those greenhouse gases then re-radiate that infrared radiation back down to the surface of the Earth, and we have additional heat retention. Very straightforward mechanism. Literally hundreds of years ago, this was hypothesized to be a potential impact of heavy fossil fuel use. The problem comes with both the warming, but then also the transition of that thermal energy into kinetic energy. And that's exactly what we see in burn patients, but it's also what we see in extreme weather events and other things. And then lastly, and I'm not going to dwell much on this, but I think it is important to highlight when we talk about climate change, is the issue of chemical equilibrium, where carbon dioxide in the atmosphere equilibrates immediately with carbon dioxide in seawater, in any water body, but seawater is the most important. About 70% of the ocean surface is covered by it. And it changes the pH, and that change in ocean chemistry impacts ocean organisms and has big implications globally for reef ecosystems and for fish and other things which are important for nutrition. And you can see evidence of all of these mechanisms unfolding right before our eyes. So this is global average surface temperature in degrees Celsius since the pre-industrial age. And you can see there's basically been a steady warming. Can't read without a line. You can't tell exactly that it's exponential. It's a small exponent, but it is exponential. And importantly, we crossed this threshold, which some of you may have heard that 2 degrees is a very dangerous threshold for us. There's actually quite a bit of research looking into 1.5 versus 2, and found that 1.5 poses a lot of risks. 2 is definitely something we very much want to avoid. Unfortunately, we crossed that 1.5 degree threshold for a year last year. There's debate about what it means to cross that threshold, but from my point of view, we crossed that threshold. We had recorded temperatures over 1.5 for a sustained period of time. We will see what the future brings, but our warming so far has continued to be. Our emissions are increasing and our warming seems to be on track. In terms of that thermal to kinetic energy, what you can see here when you look objectively, measurements of energy in the ocean, particularly in the upper ocean, you can see that there's been quite an energy transfer to the upper ocean. And then as time goes on, that energy transfer is also increasing to the deeper ocean. We see some of that energy in the atmosphere, but really, this is what's driving the rapid development of storms and other changes in the hydrological cycle that are so impactful in other ways that we're not going to really talk about today. You can also see it in how quickly the storms that do occur become very strong. And a couple of years ago, we had a storm off of Mexico that went from a category 1 to category 5 in 24 hours, which was historically unprecedented. We've seen with several storms since then, very rapid progression to real strength. Interestingly, these storms are kind of lumbering. So you would think that they're so strong that they would move more quickly, and that doesn't seem to be the case. In fact, they kind of sit where they go. And the problem then is they dump a tremendous amount of rain wherever they are. And you have a lot of flooding as a result, a lot of damage, which we've seen here in the US. So overall, what's happening with this thermal to kinetic energy transfer in the atmosphere is that it's having impacts on extreme events. And you can see 6 different impacts here. The first is that the intensity of these events is going up. Their frequency is increasing and the interval between them is decreasing. They last longer. They occur earlier in the hazard season, and they occur very rapidly. How many people were here in 2021 for the heat dome? Okay. So those of you who are here then this will probably resonate because that was an unprecedented event. It was forecasted only 5 days in advance. It was very early in the season, much earlier than usual for us in a heat season. Thankfully, the only thing it didn't actually fit with was the duration. It was pretty short in Seattle. It was only 3 days long. Though for the whole Northwest region, it lasted over almost 2 weeks in some places. And in BC, which had it the worst, they had the heat coupled then with wildfires, and they had a lot of really substantial impact. So for us, the duration was short, but for other parts of our region, it was pretty long. And it's an example of how changes resulting from climate change actually make it difficult, even with intact systems, early mornings, great forecasting, all of that, make it difficult for us to anticipate and deal with some of these events because they are so intense and rapid in onset. And then lastly, there's ocean acidification. And I already explained the mechanism too. You can see here, this is one relationship where there's no lag. So the carbon dioxide goes into the atmosphere, it immediately equilibrates in the oceans and then immediately drops the pH. So it's essentially a globally uniform relationship. There are some places that are a little more affected than others, and Puget Sound and our part of the Salish Sea happens to be one. So people who are oyster fans will be interested to know that we actually, most of our oyster culture, I'm not sure there's probably a better word for it, but I don't know, when we grow oysters here, it's a several $100 million industry. We actually hatch the larvae in Hawaii. And because the ocean waters are just a little less acidic there, we let them grow until they have strong enough shells that they can withstand this exposure. And then we ship them to the colder waters here in the Northwest, raise them up, and people consume them from here. So there's already, and it's interesting, if you look at lots of different systems, there's already a fair amount of adaptation to climate change built in, which is good, but it also means you're closer to a threshold of collapse of some of those adaptations. And you could argue the same is the case for medicine. In 2024, we had quite a bumper crop of billion-dollar disasters in the United States. Unfortunately, this is the last year that they tracked this, so we won't be able to look at trends over time going forward. And not all of these are climate-sensitive hazards and disasters, but a lot of them are. And when you look over time, what you see is a very clear trend of increased incidence of disasters. And these are all inflation adjusted, so it's not about monetary changes in monetary value. This is truly about the incidence of disasters. And some of it, we're putting more assets in harm's way, but a lot of it is, in fact, that the hazards are worse, and particularly hazards related to storms. And as you can see here, these storms are much more frequent than they were before. And also, they are happening, as I mentioned, more rapidly. And so the interval time for recovery is shortening, which is difficult on communities. And it's particularly difficult for responders who are getting exhausted and being recruited for mutual aid in regions, pretty much constantly in some cases. And that has implications for their mental health and other things. So as Tam mentioned, I've worked on several global assessments related to climate change. The Intergovernmental Plan on Climate Change, or the IPCC, is the UN body that convenes scientists to assess these issues and look at, excuse me, look at the impacts, look at how we might adapt, and look at potential for mitigation, which is reduction of greenhouse gas emissions. And so I was one of the lead authors on the health chapter for the last assessment report, the sixth assessment report, which came out in 2023. And we looked at, among other things, impacts on various systems that we rely on for health. And as is the case with many IPCC graphics, they're good, but they're a little complicated. You got to take some time to explain them. So the positive and negative signs are indications of effect direction. And then the darkness of the circle indicates the strength of the evidence behind it, meaning the volume of evidence in many cases. And so you can see that there are sort of variety of effects on water and food around the world. We have a number of places where we're not entirely sure what's happening, but mostly negative with some beneficial impacts in some places. And if we look at cities, settlements, and infrastructure, the picture is a little darker, literally, with a lot of adverse impact, very few marginally positive impacts, and on balance, more evidence. And then if you look at health and well-being, again, darker still, perhaps, a number of places where we don't actually have enough evidence, as much evidence as we would like. But clearly, there's a pattern here of pretty widespread negative impacts. And this is current. This is not what we expect with future climate change going forward. So happy to answer other questions about climate change afterward, but I think that sort of sets the stage for the discussions that we'll have going forward. So what are the intersections with surgical care? I am not a surgeon, so at some level this is all speculative and drawn from the literature, but the literature is produced by surgeons. And so if I'm speaking about something, it's with the authority of someone from your community, not authority that I'm taking on myself. This is a graphic generated by the American Public Health Association looking at the ways in which climate change impacts health impacts the environment, and then how those impacts on the environment affect patients. And of course, it's a population health perspective. They're the American Public Health Association, after all. But it does outline some of the ways in which patients you see might be impacted through any number of different pathways. And a lot of those are injurious pathways, but not all of them. And of course, impacts that may not need surgical care can still impact surgical care. So impacts on population displacement, mental health challenges, and other things certainly will impact your patients and mine. We share a lot of the same patients. And so you can see here some of these things like increased aeroallergens, probably not a huge relevance to the general surgery patient population, but some of these others really are more important to take into account. And there's a lot here that we won't talk about today. And so again, I'm happy to answer questions on these other things if you're interested, but I'd like to focus in more on surgical care. So this graphic is from a review of impacts on general surgery and other surgical subspecialties, and then obstetrics and anesthesia lumped together because of the intimacy of those operations in health systems. Looking at, in particular, warming, changes in extreme events and what they're calling natural disasters, sea level rise, which we haven't talked much about, but it's an important exposure, particularly for health systems in certain coastal regions, and then air pollution. And of course, there are a lot of effects on pre and post-operative care to take into consideration in terms of demand for care, impacts on post-operative care and morbidity and mortality, a whole host of birth outcomes we're not going to talk about today, significantly increased trauma burden, potentially from a number of different mechanisms, as I mentioned, displacement, and then infrastructure damage, which again, I'm not going to talk too much about today, and I don't think it's quite as relevant here in the Pacific Northwest, but it's definitely something that we in the healthcare community should be thinking more about and assessing the risk of more than we do. We don't talk about it at all. Recently, we were redoing one of the towers at Harborview, and we had a consultant, so you may have been in this conversation, who's an emergency physician. He practices in Florida and New York, I believe. And there was I guess a charrette, you'd call it, a conversation involved some of the trauma surgeons and others about how we should redesign this tower because it's going to have the ED and office suites and other things. And I went up to him during a break and said, how often are people coming up to you, because he does these conversations all over the country, and talking about sea level rise and these issues related to climate change? He said, you're the very first person who's ever brought this up to me. And we don't have these conversations when we're siting facilities, when we're thinking about continuity of operations, when we're thinking about capacity, and when we're thinking about ensuring these large infrastructure investments, which I found rather stunning, frankly. But anyway, consistent with what I see, which is that generally we're not talking about this stuff nearly as much as we should. For surgery, I'm going to highlight a couple things and then move into specific thermal issues. So another thing that I do is work on the Lancet Countdown on Health and Climate Change. This is an annual inventory of climate change impacts, generally health impacts, efforts to adapt and reduce greenhouse gas emissions in the health system, and then funding flowing to support those things, and also literature and other news, basically discussion about climate and health. And there are about 50 different indicators that we track. I lead the adaptation work group for the countdown. This is from working group 1, where we are looking at impacts. And what we see here is there are a lot more heat-related deaths globally than there would have been previously. And we're now over about 500,000 a year, which is pretty substantial. And there is a balance of a reduction in cold-related deaths. I think that's important to acknowledge. But overall, we still see that the impact of climate change is adverse and negative and really impacting productivity and a number of other things this way. We're also seeing a substantial increase in fire danger globally. There's some interesting dynamics in terms of how much area is burned in certain places, but in our neck of the woods, literally here on the the west coast of the United States, we definitely are seeing an increase in fire risk, and that's going to continue. And this is important for you, both in terms of burn risk and then injuries to firefighters and others, but also because of the air pollution that's involved in smoke. And again, you're not going to see necessarily these patients immediately. Those we will in the ED. This is associated with some increased cardiovascular complications and cardiac dysrhythmias and other things like that. This is very toxic. And you see this with burn patients who are exposed to smoke, but you also see it in the general community. It's about this kind of small particle from wildfires, about 3 to 5 times more harmful than the same particle from urban air pollution. So really potent stuff, and increasing deaths. And for a long time, we were seeing a decrease in attributable deaths to air pollution in the United States. And that has started to change course because of wildfire incidents in the United States, particularly in the West. And then there's the health facility supply chain issue. So I mentioned before, strong storms, dumping a ton of rain. Hurricane Helene dumped rain well into the Southeast, and it flooded hospitals there, as you can see, but it also damaged the Baxter facility that manufactures IV fluids. And for some reason, I don't really understand, Baxter, which is very good at what it does, had 60% of the market share for IV fluids and dialysis fluids and other things for the entire country at this one facility. And so when this facility was knocked out by Hurricane Helene, and this was in an area that everybody thought was kind of a climate change haven in terms of likelihood of exposure to a lot of hazards, they stopped production entirely. And immediately, health systems across the country had to react. All they had was their stockpile of these fluids in hand. And some started hoarding, and a very few shared. Large health systems like UW Medicine actually did reasonably well with this, but the backstory to it is really interesting. I give a whole lecture to this to the medical students about health system resilience, because they put a ton of time and energy and resource into managing this now very scarce supply of IV fluids and dialysis, but also changing all the treatment protocols. And some of you may have experienced this at the time, that we went from a lot of IV administration of many medications and things to oral administration where possible. We're trialing this with a bunch of different, certainly felt it in the ED. And in fact, found that we could administer a lot of stuff orally that we never thought we could. It was just more convenient to administer it through an IV. And that freed up the fluids for places where we absolutely needed them to be IV. And we were able to weather this without canceling any surgeries, without canceling any outpatient care. And really, I think at the end of the day, we're the better for it. But a lot of places did not have that experience. And this has happened several times before with other hurricanes. It impacted supplies when they hit Puerto Rico and with Maria years ago. We don't seem to really learn the lesson. And interestingly, and I did the same thing in my lit review for this talk, but in all of the literature on these issues, climate change is never mentioned once. Not once. In the surgical literature that I'm talking about, climate change does come up a lot more. So I think as a specialty, general surgery is doing a better job than some of these other groups are in terms of acknowledging the impacts of climate change and that consideration. So let's talk about thermal injuries. Before I do that, I want to outline a framework that I have used for a long time because my community, the climate and health community, uses it. But I think it's actually very helpful here too. We're going to focus on risk, potential for harm. And it has basically three components. It has the component of the hazard, so here represented by weather and climate events, vulnerability, so vulnerability is susceptibility to harm and risk factors essentially that you often think of epidemiologically, and then exposure, whether a person or a community was exposed to the hazard that poses the threat. And there's some other relationships here between climate and development and other things we can talk about if you'd like. But the main focus of this graphic is that that risk flywheel. So we're going to talk some about the hazards first, but what I want to recognize that in many cases the risk is a function of the exposure to the hazard mixed with the vulnerability mixed with exposure, and all of those, of course, are opportunities to intervene as well. So in terms of the hazard for thermal extremes, what we are seeing, as will be no surprise, but based on what we've already talked about, is that heat extremes globally are increasing. And what we see is that both the event frequency and the duration is going up. And the same, or the opposite, holds for cold extremes, which is probably intuitive, but here's proof. So the mean frequency globally of cold extremes is going down. And when they do happen, they're also lasting long, not as long as they used to. I tried to find some evidence of variability in the climate, and this paper did talk some about combined events, but it didn't quite get at what I was interested in, which is the question of whether there's this perception that cold events actually are becoming more frequent, and I'm not entirely sure why that is, because the evidence is very clear globally that these things are going down. And you can see it maybe perhaps more easily when it's visualized. So this is for heat, all the trends basically in this part of the distribution. These are the ones that are statistically significant. And then this is cold. And what you're seeing here is these are becoming less intense. The cumulative magnitude of these events is going down. And you see that relationship particularly in the Arctic, but then also in parts of Africa and South Asia in particular. And so this has implications for frostbite. There's in the literature a lot of concern about the potential impact of climate change on frostbite because the perception of weather variability going up and the intensity of certain cold events going up. And what we see with frostbite, of course, is that there's a strong association with cold climate. So this is a disease that you see in places that get cold enough to harm people in the external environment. It is moderately associated with episodic cold events in those places, historically. And as you might expect, you see more severe injury associated with certain comorbid conditions and then acute conditions like intoxication. And there's a lot of, as I said, hypothesis in the literature around relationship between climate change and frostbite. The findings are not necessarily clear, and what in fact it says to me is that here, what we're seeing are interactions between the hazard in maybe a little bit surprising ways and vulnerability. And vulnerability is increasing in a lot of places, some of it from climate change, a lot of it not. And therefore, you're seeing more frostbite in the community, but it may not be because we're having more extreme cold events. Pathophysiology of frostbite, this is not a talk focused on those things, but it's important to recognize that it's a complex pathophysiology and that the treatment of frostbite can actually result in more injury if it's not done very carefully and in the right context and with the right timing and with a lot of expertise, which you have. And so I'm not going to belabor any of that with you, but I think it's important to recognize that this actually may be part of the problem more broadly, that the complexity of the pathophysiology and a lack of full understanding about the best way to treat it is impacting care for these injuries. So, of course, even in the classification of frostbite, there's variability in the literature. Some cases there's 3 different classifications. Some cases are 4. They try to make it analogous to burn injuries and disanalogous and more aligned with the actual pathophys of frostbite. Suffice it to say, there's a wide range of injuries I imagine you are familiar with, and various surgical and non-surgical, but invasive treatments for different cases. And in this systematic review and meta-analysis, they found that certain strategies, including thrombolysis, iloprost, and other things, of course, are indicated in these cases, but they also noted that there's really quite a bit of, from their point of view in the literature and otherwise, confusion is probably too strong, but just a wide variability in treatment protocols and strategies and recognition of best ways to approach frostbite and manage this disease. What we do see here in the United States is that incidence is slowly increasing. This is the most recent data I could get through 2018. It does look like those trends are increasing, whereas trends for burns are stable. What we see is patients who experience frostbite are more likely to be male. On a national scale, they're more likely to live in the Midwest, and they tend to be poor and addicted to drug, alcohol, and nicotine. And they often are homeless. And I think this is consistent with what we see here. We also see that this has a really significant burden of injury, burden of disease. That amputation is very likely in these patients, or much more likely than it is with burn patients with similar patterns of injury. Interestingly, so I did find in my review of the literature for this talk that there's a fair amount of interest-grabbing titles in literature, but then the actual analysis doesn't address the question. So there's climate change as a title, and I think meant to either be provocative or highlight a supposed trend, but then the analysis doesn't really speak to that. And this was one of those cases where there was a discussion of pediatric frostbite injury and a sense that pediatric frostbite injury is increasing across the country. And one of the things that they did that was quite novel was pull together a bunch of different data sets to examine this question. And yet they didn't report a trend, so I can't actually say whether there's an increase in pediatric frostbite injuries, and they didn't associate it with any specific weather events. But what they did find is that there's substantial burden of disease in the kids who are injured. And then they looked nationally and they found that, in fact, what we see is a dissociation between cold and significant frostbite impacts in kids, which I think actually speaks to, again, this perception around maybe climate variability, these quick events, and maybe the events are less common than they used to be, so people are less prepared. And so this extends to children. There probably is a mix of other social vulnerability and homelessness and other things in this that we're not seeing. But the take home from their analysis for them and for me was, in fact, this is an issue of vulnerability that we need to look more closely at. We need to think through how this happens, and then where these kids and adult patients present, are the facilities prepared to manage frostbite, to diagnose it and treat it appropriately. And what they recommended was targeted outreach, enhanced surveillance, and standardized treatment protocols in these areas that are hotspots. And we are doing that here. I want to highlight Dr. Stewart's work in this space, supported by King County. There's a formerly robust, we're seeing some budget cuts, so hopefully the program will survive, but emergency medicine is involved with this, dormant surgery is involved with this, and there's a whole cold weather preparedness protocol here. And I think we're also doing what we can to protocolize the treatment of these injuries and make sure that our trainees, when they go out into the world, particularly around the West Coast, but certainly other places too, are well prepared and ready to educate their colleagues and prepare the systems that they're a part of to support the care of these patients. So in summary, what we see with frostbite is a clear association with extreme cold, but some patterns in the hazard frequency that actually would suggest that maybe this should be decreasing. But in fact, what we see is it's increasing, and this is probably related to vulnerability factors and really provides opportunities for thinking about prevention and improved readiness. Even though the hazard is maybe decreasing, that has interesting and complicated relationships with preparedness overall. Pavement burns. So this is a picture that I took when I came onto shift the night of June 28, 2021 in the Harborview ED. I had never seen a patient with pavement burns during an extreme heat event before. I had worked in a very hot place in Atlanta. That's where I trained and practiced for a long time. Had never seen this and was surprised to see it here. So I took a picture of it. And that sparked an interest in these issues for me more broadly, and a bit of a journey of discovery, learning that this is in fact becoming a significant problem for a lot of communities and for burn centers in those communities, a real challenge. So contact burns or pavement burns result from skin contact with a very hot surface in the environment. And they're usually in dependent areas. And unlike other burns, they tend to progress after the initial injury, which makes treating them a little more challenging. And as a result of that, they have a higher morbidity and mortality than burns of other sorts. And there's a lot of literature on this from the burn community. Interestingly, literature that both looks at the exposure science and also at the health impacts. And it tells a very clear story from my standpoint. One of the papers, this was published in 1995, was called Streets of Fire, and it looked at different surfaces and their temperature at different times of day. And here, 44 degrees Celsius is the critical burn threshold, essentially where if you have exposure to a surface that hot for seconds, you can expect to have a second degree or partial thickness burn. And what they showed is that many common surfaces in full sun cross that threshold pretty early in the day in places like Phoenix. Around 9 o'clock, you start to see that these are dangerous, and they don't cool off enough to not be dangerous until about 5. Even in shade, they will cross that threshold a little later, and shade is somewhat protected, but still quite dangerous even in shade in those locations. If you map out places like Maricopa County, where Phoenix is, you can see this, that in fact, that it's like the whole place is forest fire. You don't want to come into contact with the surface. This is where they've done a lot of work to extend that exposure science into epidemiology. So they started in 95 with a retrospective review looking as far back as 1986 through 1992. They reviewed 23 patients, and they built on some pioneering work that had been done in the 1940s and 50s, looking at the logarithmic relationship between the surface temperature and the time required to cause burns. And so in most places, between 10 and 5, you can get a partial thickness burn in Phoenix if you have skin contact for just 35 seconds with the surface. And at peak temperature, the warmest time of the day when the sun is most intense, it's only 2 seconds. So it's very, very quick. most of those burns happen in July and August, and all of them happen on hot, sunny days. So it's very clearly an environmental exposure. And this is the distribution of injuries that they saw. As mentioned, all independent areas. This was something that I think prior to that point really had not happened much, and there wasn't much discussion of it in the literature. This was the first paper that looked into it with any depth. They found there were a lot of different interactions between these other conditions here, and they found that generally these patients had about 10 to 15% total body surface area, and that altered mental status was a major driver of impacts. If patients were altered for any number of different reasons, as you can see here, the number on the list, they tended to have a much more significant exposure and a more significant injury. And here's one of the images that they included, highlighting the dependent distribution and the widespread burn in this patient. So when you look at pavement burns versus scald and flame burns, what you see is that roughly similar amount of burn surface, but these are much more expensive to take care of in terms of normalized to percent of the body surface area that's burned, 13,000 versus almost 2,000, and that they stay a lot longer, 12 days versus 2. And this is largely because they go to the ICU more often, they stay in the ICU longer, they have more operative procedures, and they tend to have to get more skin grafts and then go back for procedures more often. And it's pretty substantial odds ratios between the two in terms of need for debridement and recurrent debridement. As I said, altered mental status is a really important driver here, that when someone collapses for any number of reasons, they tend to then lose all their protective reflexes. They're on this hot surface for, even if it's a pretty short period of time, they'll get injured from it. And so they have significantly worse outcomes, more area burned, more cost, et cetera, for all the same reasons that we've outlined. And it didn't appear to depend on the kind of altered mental status. They were intoxicated or versus had a syncopal event for some other reason. As mentioned, these injuries tend to persist after the initial thermal insults, and that's because they're dependent. And so just when we take care of patients and they're recumbent, they tend to be lying on those burns, so putting additional pressure on them, reducing the perfusion. And so that, and then also the perception of the thickness is often difficult. And so they recommend that there's a lot of considerations around managing these patients in the ICU with strategies to relieve pressure and turning and other things that I'll be interested to know how they're incorporated into care in our burn unit. I presume that this is already low-hanging fruit that we've picked. They did revisit the Streets of Fire analysis more recently because they had perceived that they had a substantial increase in these burns in their burn center, and it wasn't all due to population growth. So quickly, I'll go over some of what seems to be happening there. So 23 patients in the first case series, 225 in the second. And what we saw that over that period of time, there was an increase in temperature, the ambient temperature in the community. Urban heat island probably amplified that further. And they saw the same patterns that they'd seen before. These patients were badly injured, a lot required skin grafts. Fatality rates weren't really reported in the first series. In this case, they were about 6%, which is high. And they had a lot, the people who died had higher burn percentage, and then also, again, altered mental status was a significant driver there. And when you look at temperature relationships over the time in that area, what you can see is climate change has very clearly driven this increase. It's not only that, again, there's an interaction and vulnerability, but they're receiving expert care and from a highly trained group of individuals in a community that actually is pretty invested in reducing heat impacts. So they're doing what they can to manage vulnerability on the healthcare side, but the hazard is increasing, and in this case, the hazard's winning in terms of the actual impacts on patients. And you see this in other hot parts of the country. In Las Vegas, you see another similar set of associations. They looked at associations with daily maximum temperature and then developed this risk curve that, at least for their region, has been generalized yet. Shows that basically anytime the temperature is between 95 and 105, which is quite a bit of the time in Las Vegas, the risk is high. But then when you get over that, you get really extreme risk. And they don't have as many days in this category as well, they have some. The number is increasing pretty regularly. The last thing I'll say about this is that there's also now an interaction between heat stroke as a driver of ultramental status and collapse that we never saw before. And this is, we're seeing reports of this from all around the world, but we certainly are seeing it in the US. And just like any other patient who has ultramental status, these patients have worse outcomes. But it's important for us in the emergency department, well, pre-hospital care, and then us in the ED and you in the burn treatment part of these patients, to recognize these patients need to be, you have to recognize that heat stroke quickly, which can be difficult depending on if you don't have a lot of history about why the patient is in front of you. You need to quickly get a core temperature, and you have to rapidly bring it down, or else the heat stroke will kill them before the burns will, the high case fatality rate. And so we are clearly seeing an increase in pavement burns. Still a relatively small proportion of overall burn injuries, but increasing, and substantial morbidity and mortality. Ultramental status is an important driver there. And then heat stroke is an increasing concomitant problem with these folks. So on to wildfires. All that heat and also changes in the hydrologic cycle are affecting our experience with wildfires. And so we are seeing changes in fire weather, which is hot, dry weather, all over the world. And this is the baseline fire weather distribution. And what we're seeing is a significant change, an increase in fire weather in many parts of the world, including the western part of North America, but many parts of South America, Africa, et cetera. And what you see here in the United States, this just gives a higher resolution picture, is that for the most part, we're seeing pretty substantial increases in fire weather, which is not fire, it's just conditions that are conducive to fire over the last 30 years or so. And along with wildfire, or increases in fire weather, we're seeing increases in fires. And so what you can see here is that the mean number of severe fires is increasing globally quite steadily, and again, with an exponential curve. And the length of the fire season is going up. If we look forward to 2 degrees of warming, so we're not quite there, but we'll be there probably in the next couple decades. You can see this is the distribution of fire weather. And then at 3 degrees here and 4 degrees, start to see really widespread increase all across the whole US and many other parts of the world. And Washington, of course, is at risk for this. We have a lot of biomass as a result of all the rain that we get in the winter. And then, of course, we have wildfires in summer. Some years are bad, some years are not. But there's increasing concern that we are going to have a massive fire event here. In fact, I think a lot of people consider it to be inevitable. And there are strategies you can employ to reduce the warming. But what we're already seeing is, with that global increase in fire, we're seeing an even steeper increase in fire in the Pacific. The real challenge is at the urban wildland interface, UWI. We're building a little closer to wildland areas than we should, from a fire perspective, at least. And what you can see is when you have fire, big fires are blue, big fires that become disasters are red. And the big fires that become disasters are in highly populated areas. They're in the margins of those highly populated areas. Those are the ones that are going to send a lot of patients to burn centers. We have experience from this in Australia principally, but then also increasingly from the US. They had some really bad bushfires in 2009. They activated their regional burn network, and they were actually able to absorb this massive influx of patients. But it was very helpful to them to learn about what these patients presented like. And it took roughly about a day for a lot of these patients to get to the burn centers. So they were cared for initially at outlying places. Again, a theme of needing to make sure that the referral centers know what they're doing in the initial management and know when to send. And that these patients, some of them had some physical trauma and smoke inhalation, but a lot of them were really just burns. And there was a fair, the number of deaths here is small, but the total number of deaths in this event is large. Burn patients come to us with the burns, but they also come with smoke inhalation injury, which of course is not unique to wildfire burn patients, but it's pronounced in wildfire burn patients because they've been exposed to a very high heat event. And there aren't a lot of other household chemicals necessarily, though some of these people are coming from structural fires within wildfires and then getting to us. So it's technically a wildfire, but in fact, they are exposed to all these other chemicals that are in structural fires. And they have bad thermal injury to their upper airways, and they have a lot of chemical and other irritation lower down, which has implications for airway management and management in the ICU. They are a distinct population. They have higher mortality. They have longer lengths of stay. They tend to have a lower chance of going home without any assistance at the end of their care. And they have a higher readmission rate. And again, I don't know about our experience here, but I would be curious to know if it accords with that or not. That's clearly what the literature suggests, both in Australia and elsewhere. And these are the the lessons that they learned from their wildfire mass casualty incidents. High mortality, few survivors. The ones who do survive are badly injured. They really emphasize the importance of getting people and expertise out into the field as quickly as possible when these events take place to facilitate that distribution and triage in early management and getting the right people to the highest level of expertise. And then when they do get to the burn center, they require quite a bit of resource. They require a lot of OR time, they require a lot of staff time, and they require recruitment of expertise from other services to support these patients. And you can see that here, that they had this surge in all of these other consultant services, extending into laboratory, infectious disease, social work, et cetera, because these patients have so many other needs. So in summary, for wildfire burns, we see that they are associated with the most massive events that tend to occur in populated areas at the periphery, and that there's high mortality with these events overall, a lot of psychological trauma, and the patients who do survive have higher morbidity and mortality than other burn patients that you may be used to seeing. And the response is quite resource intensive. So when these events happen, and we can expect that there will be some substantial events in the Pacific Northwest in the future, just by the nature of our ecology, and then also because the climate is changing here, we're going to need to respond in a substantial way. And I actually reached out to Danica Little, our response officer, to ask what our wildfire response plan was. And she said, as an institution, our facilities are actually not directly threatened. So from that standpoint, we have assessed this hazard threat to be low, but it certainly would fall under our mass casualty plan, and we stand ready to take care of these patients in the event of a regional disaster, which I think is likely in really just a matter of time. So, synthesis and management. Coming back to this framework of hazards, vulnerability, and exposure, we see that hazards are changing in different ways for different issues that we've talked about, decreasing probably for burns, increasing for the others. Generally, the exposure follows the hazard distribution, but not always. I think people have complicated interactions with weather, right? So if they perceive that it's safer to go outside, but then all of a sudden you have a cold snap, they maybe are going to be exposed to extreme cold in a way they might not have been before. And you can't forget the intersection with vulnerability. And a lot of that's not driven by climate change, it's driven by other things. Increasingly, though, climate change is just part of the mix. And it's driving changes in housing prices now and house insurance rates. And that is interacting with homelessness. And so I'm not keen to ascribe too much to climate change. It's just that we have to recognize that there are all these interactions that are important to take into consideration. And each of them allows for opportunities to reduce risk. So we can reduce risk by reducing the hazard, reducing greenhouse gas emissions, and then doing things like promoting shade, promoting fire prevention. I know this is not what you do, but we can support it and lend our recognition to it as an important measure. We can do things to reduce exposure. So highlighting early warning systems, promoting evacuation readiness, thinking about fire prevention, and doing drills. I find, in fact, that we often stop short of this. We really don't practice it. And if you practice it, you find out actually there are a lot of things you need to fix in your plan. And then lastly, there are strategies to reduce vulnerability. And that's, I think, really where we have a role, where we can enhance prevention messaging, we can invest in our burn care systems, we can push expertise out into the community as much as possible, we can build capacity, we can support capacity protocol development, and we can stress test our own systems or do our own drills, do a mass casualty event focused on burns with a major wildfire response in the Pacific Northwest. We haven't really tested ourselves against that scenario, and thinking through that would probably be useful for us as a community. All of that said, we're still going to have limits to what we can do. And we have to recognize that there are going to be impacts and costs as a result of those limits to adaptation. We've published some strongly worded encouragement for the health system to think about the evidence of what's happening with climate change and exposure to the health system in our patients and act accordingly. We will see. I do think there is some increased attention to this issue in healthcare, and I really, again, appreciate the opportunity to come and talk with you about it. That said, there's not as much evidence. There are different kinds of evidence that we rely on in healthcare. In terms of climate and health, we have a lot of evidence of harm. We have very little evidence generally about prevention and therapy, though I would argue that with burn care, we actually have quite a bit of evidence and a strong commitment to evidence-based care, which is important, and we can lean into that. You have a lot of evidence around frostbite and burns, and a lot of good process in that space. There's, in your own literature, a call for some more conformity around quality improvement and other things in this space, which is a little distinct from traditional research. But we have good strategies for improving the quality of our care and testing that in a cycle, a quality improvement cycle. This is something that healthcare does well. Unfortunately, it doesn't do it quickly. So average time from the development of an effective intervention to its implementation in 50% of the places where it's required is 17 years. So I want you to go back to that curve and think about what the climate is going to do over 17 years as we disseminate these important strategies. We may struggle. So I'm going to close in a second, but first I have a couple plugs. And the first is healthcare is a substantial contributor to global greenhouse gas emissions. About 8% of emissions in the United States come from healthcare. Surgical care is a big part of that, which makes sense. It's very intensive, and it needs to be. But there are ways that we can reduce that impact, particularly through changing our anesthetic care, which I know I'm not talking to the right group for that, but you guys are adjacent. And then converting to a lot of other strategies for reducing energy use in the OR. And it actually saves money. It's just a matter of will and inertia and overcoming inertia. You all have expertise in this space. Barclay shared these papers with me. This is work that your group has been doing around reducing carbon emissions and responding to climate change for years. And I encourage you to continue to lean into that. I also encourage you to come and join our Climate Change and Clinical Practice Symposium. We're going to have the third one this year. We've had, they're always at the Center for Urban Horticulture. This will be on March 12th. Here's the registration link. And I'd love to see you there because we really are now having a nice, broad conversation within UW Medicine and with other health systems in the region about what to do, both to reduce our footprint, but also to change our care strategies so that we're adapting appropriately. Here are all the references. I have this in case you want to download the slides, and I put all the references here in case you're interested. I don't know how much time there is for questions, but happy to take them.
Thank you so much, Dr. Hess. There's actually no time for questions right now because we're over time, but I'd encourage anybody with questions to email dosadmin@uw.edu, and we can go ahead and forward any questions.
I do have a gift for you, though, Dr. Hess. This is, of course, our obligatory certificate, but I think you'll appreciate our paperweight. Our paperweight is designed with a lodgepole pine as its main theme. And the lodgepole pine, if you don't know, is one of the first things to sprout after a fire. And so I hope you appreciate that. Thank you very much.
Thank you.